This session is specifically for students that are in the higher grades that are doing chemistry. So if you're in grade 8 and 9s, this session won't apply to you. But if you are a chemistry student in grade 10, 11, and 12, this is a session that is going to benefit you greatly. It's going to be a 2-hour masterclass. So that means we're slightly going to finish just around 8 o'clock this evening, but it's worth every single time, every single second of your time. With Mavo, who is no stranger to us. Of course, he's got his BSc, and he's also he's got a master's in engineering as well. Mr. Solomon worked as a tutor in 1993 and has continued to work as one, having left formal employment as an energy analyst at Eskom. He decided to come back to his hometown, where he now gives back to the community, and founded the Etevecha Foundation. And through this foundation, he aims to give back and share his knowledge through tutoring. So a BSc in engineering, mechanical engineering, and a master's engineering degree. He is more than equipped, and also one who's always a scholar, always so curious. And he's taken the time over the past couple of days to go through a series of exam papers over timeline of 5 years, just to be able to identify trends. He's going to share his insights with you, and also how to tackle those level 1, 2 questions, whether those are quick marks, and then really focus on those top marks. If you're looking to get distinctions, you should be mastering level 3 and level 4 questions. The how is in the next 2 hours. So I'm going to hand over to Mavo. Moro Tigela, how are you today? Welcome. Hello, Mavo, are you there?
Can you see me? Can you hear me?
Right. There you are, yes.
I'm good, Sisolutu. How are you doing?
Very well, thank you. Looking forward to this masterclass in chemistry. I'm going to hand over to you.
Thank you for having me.
Sure.
Let me do my thing. Let me share my screen.
Oh, wait, while Mavo does that, I want to let the FGLers know that we are also going to have a quiz at the end of this session. It's going to be a quick quiz of about 30 minutes, and there's going to be 1,000 rands for the winner, 750 rands for the runner-up, and 500 rands for the second runner-up. So pay attention, really engage in this session. It's all about mastering your chemistry and making sure you leave no marks on the table. Right, or back to you, Mavo.
Thank you, Olutu. Hi, everyone. I'm sure, I think that's better. The light is in my eye. I'm happy to be back again. It was nice listening to Sibabalwe talking about methods that he implemented to study. And I hope all of you, not some of you, all of you will take whatever you feel applies to you, and you will use it to advance your own learning as you prepare for the next bit of exams, which is, of course, the trial exams. So what we are doing here is in aid of that. It's a masterclass for grade 12 chemistry. When I was asked if the grade 11s and grade 10s should pop in, I said, yeah, there's something to learn for themselves in the future, especially the grade 11s. But certainly the grade 10s can benefit from understanding what the chemistry is going to leapfrog like going into the following years of their high school. So I wanted, Cindy asked me to speak on the issues of levels and how the exams pan out in terms of grading the questions and giving you a fair chance to pass. So a level one type of question is a question that requires you to know stuff. You should really pin down in your memory definitions of concepts, of phenomenon, properties, laws, identifying chemical species, naming chemical species or chemical compounds. Level 2 is definitely the application of that knowledge. So for instance, you can set up a calculation for Kc in a chemical equilibrium calculation. That's my example there. Or you need to be able to write down a chemical equation, whether it's a chemical equation in acids and bases, or chemical equilibrium, or redox reactions. And I want to also squeeze in IUPAC naming. I think obviously you learn the rule, you learn the property of how you name an organic compound. So IUPAC naming is us testing you if you understood that. So when you give your compound, you should be able to name it. Level 3, basically level 3 is the beginning of calculations. You should be able to calculate, to do calculations that require you to use multi-steps. You should be able to interpret data. You should be able to contrast and compare graphs and all of that stuff. Those questions, their marks are level 3 type question marks. And obviously level 4 is the one that everyone threatens you about, which is a higher order thinking. Sometimes you'll be in a redox calculation and you have to implement a calculation from a different type of section of your physical sciences, even using a physics calculation. I've seen some nice questions where your knowledge of what a potential difference is could help you do calculations in electrochemical, electrochemistry, electrochemical reactions. So that's the lay of the land in terms of what the levels themselves mean in how your marks are graded. I took a CAPS document and I looked at how they usually spread, or how they recommend marks are spread between the levels. So remember that for level 1, all you're doing is recalling facts, right? So every time a question asks you to recall something, that's a level 1. So that's about 15% recommended in the question paper. So you can't go into an exam and be like, I'm just gonna know only the facts. I'm not gonna know any calculations. I'm not gonna be able to compare graphs. I'll just know all the definitions, all the laws, all the properties. Chances are you'll be restricted to less than 20% in terms of your passing. So understanding is key, and that's a formidable part of the question paper in both paper 1 and paper 2. You know, the center around 35% and 40%. So the two of the levels should give you over a 50% pass if you're spot on. If you want to get high marks, obviously you start delving into the level 3 ranges. You'll see later on that that might not even get you to a distinction type range of marks. So your level 4 should also be as equally good, even though it is a small percentage of the marks. I was given a task to spend some time studying the past papers and just figuring out how the marks are spread. So what you have on the screen here is how the marks are spread by topic. So the top half of the data is for the DBE, and the bottom half is for the IEB. Ignore my error there. So in the DBE NSC exams, you get organic chemistry, rates of reaction, chemical equilibrium. Yeah, my typing is not good. acids and bases, galvanic cell, the galvanic cell in electrochemistry, and the electrolytic cell. I like splitting them so that you can see how much they're worth in an exam. Because one is the second last question, and the other is the last question in the examinations. So I'm looking at 2019, 2022, 2023, 2024. I've skipped 2020 and 2021 because of COVID. Especially in 2020, there was hardly any teaching in the predominant public schools. So even the examination questions were not as intense. So they are an outlier. And in 2021, the same, they were still recovering from the shutdowns in 2020. So I'm focusing on 2019, 2022, 2023, and 2024. That should give you enough of a trend as Babalo has said. So in the paper 2 chemistry question in the physical sciences, you'll notice that in 2019, organic chemistry was 30% of the paper. In 2022, it was about 29%. In 2023, it was 33%. Last year, it was 34% of the paper. So that's a decent chunk. If you just look at the last 2 years, it's about a third of the paper. So organic chemistry is definitely where you get your marks in your chemistry. So you should be able to go in there, and you must know all of the compounds, alkanes, alkynes, maybe not so in the IB papers because they don't seem to worry about alkynes, and then alcohols, aldehydes, esters, ketones, even the polymers. So you should know all of your compounds. Yeah? You should know what they are, what they look like, what their functional groups are like, how to name them in terms of the IUPAC convention. And that's all in chemistry. And you must know all the equations, the addition equations, the elimination, the addition reactions. Sorry, not equations. Addition reactions. You must know the substitution. You must know the elimination reactions, polymerization reactions, and so forth. Okay, so you must know your what do they call them now? Your reactions. So you must know all your reactions. And then moving on, the next set of questions is on rates of reaction. In 2019, it was about 13%, 2022, 13%, 2023, about 13%, and last year it was 11% of the chemistry paper. So that's kind of stable. So between organic chemistry and rates of reactions, you're not even hitting 50%. You're sitting at 43%, right? In 2019, 42%, 46%, and 45% in 2024. The next section is chemical equilibrium. It's about 16% in 2019 of the paper, 14% in 2022, 13% in 2023, 13% in 2024. Even that one, you can see it ranges from 13 to 16%. It's not, it's kind of stable. It's not up and down. Acids and bases. In 2019, there were 12% of the paper. In 2022, 12%. In 2023, 12%. In 2024, 11%. Even that is very tight, between 11 and 12% of the paper. The galvanic cell, is 9% in 2019, 10% 2022, 8% in 2023, 8% last year. Yeah, so in the DBE papers, that's kind of stable as well. And electrolytic cell, 6% 2019, 9% in 2022, 12% in 20, or 8% in 2023, and 9% last year. So that's how they're split. This column here that also says percent is basically accumulating the percentages for each section. So if you wrote the organic chemistry section and the rates of reaction only, you get to 43% if you got 100 marks, 100% of that, sorry, or 150. So it's not 150, it is 59 of those marks. If you got all those marks, all those 59 marks, you get about 43%. If you included chemical equilibrium, that takes you to 59%, 71% with acids and bases. You start getting into the distinction range. If you'd mastered all of the other sections and you start including the galvanic cell, this is the same across the years, right? Okay, so now let's look at the IEB paper. Excuse my error there. So this is the IEB section. In the IEB section, question papers, as I looked at them, there is an extra section for chemical bonding. Most of you will remember chemical bonding, those in the DBE. In grade 11, it was intense, and you still use a lot of that reasoning in your grade 12 chemistry, but you don't get actually chemical bonding specific questions. You might have to reason why certain boiling points compare a certain way, explain why certain molecules are in organic chemistry are bonded in dipoles, or hydrogen bonding and so forth. But in the IEB paper, this is a specific section that's thrown in there. It was 12% of the paper in 2019, 9% in 2022, 7% in 2023, 12% last year. Also, you'll notice that the totals are different in the examining board. So this one is an anomaly, the 2019 DBE paper, because it included, and I had to exclude it, it included a section on fertilizers and basically chemistry, chemical systems, industrial chemical systems. So I had to take out the 12 marks, which would have brought this to 150. And these totals of 150 here include the multiple choice questions, the 20 multiple choice questions. You see that they accumulate to 130 of the paper. And then for the totals, so that I calculate the accurate percentages, I just added the 20 marks from the multiple choice questions. Also, in the IB papers, you see the total marks there are about 200. So that's because they, suppose, wanted to include chemical bonding. Yeah, that's that. So we look at the years, 12% of chemical bonding, 9%, 7%, 12% in through the years. So the range is from 7 to 12%. And then rates of reaction, 8%, 12%, 12%, and 10% in 12% last year. So that's a range of 8 to 12% in terms of what the rates of reaction questions compose, or the portion of rates of reaction questions are in your IB questions. and then 13% for chemical equilibrium, 12% in 2022, 11% 2023, 12% in 2024. So that kind of stable around 11 to 13%. And that's not too far off from the DBE composition. Acids and bases, 11% in 2019, 14% in 2022, 14% in 2023, 14%. That's pretty tight, right? I mean, except for 2019, which was at 11%. But for the last 3 years, acids and bases have kind of been 14% of the entire paper. Galvanic cells, 17%, 12%, 11%, 11%. That's also pretty stable, ranging from 11 to 12%, except with the anomaly of 2019. And the electrolytic cell, 10%, 14%, 11%, 12%. And I mean, those are not too far off from the DBE ones, if you look at them closely. And then organic chemistry is not as high as the 30% we saw in the DBE at the IB papers. It was 21% in 2019, 19% in 2022, 24% in 2023, and 20% of the paper in last year. So that's that. And also you start seeing here that to get into the distinction range, you have to answer level 2s to level 3s accurately. And to get over 90, you really need to answer some of those level 4. So sorry, these are not levels, but you really need to answer your organic chemistry well as well, because that's where your big marks are. Okay. I think that's all I want to say about this particular slide. I also have a slide in terms of levels. I broke down the marks in terms of levels. You see the same totals I had in the previous slide. I have IUB correctly here. And so level 1 in 2019 got you 19% of the marks, gave you 19%, 2022, 13%, 2023, 32%. I'm not quite sure. Oh yeah, so the other thing is also, I have to use my discretion in terms of assigning whether a question is a level 1, level 2, level 3, level 4 type question. So, but I don't think I'm far off from the actual reality of the levels. And so the level 2s in 2019 was 17%, 23% in 2022, 17% in 2023, and last year were 18%. And you'll notice that combined, they hover around the 14% we saw, the 40% we saw earlier in the CAPS document. And then level 3, 32% of the paper is level 3 questions in 2019. In 2022, it was 31%, 2023, 21%. Last year, it was 26%. That gets you about up to the 60-70 range if you answer level 1s to level 2 questions. And then what I tried to say in the previous slide comes out here is that you start getting into the distinction range when you start playing with the big boys, answering level 4 questions. So 17%, 19%, 17%, and 20% of the paper over the years. IB, so about 23 to 27%, the range of level 1 questions of the IB papers. The level 2 questions in the IB papers have a range of 25 in 2019, 32 in 2022, 20 in 2023, 26% in 2024. So they range between 20% and 32%. Combined, they're sitting at about 40, 55, 47, 51%. Okay, so you in the passing range. You only start passing well when you do the level 3 question. Basically, this tells you you don't have enough marks just from recalling facts or showing some understanding whether something is increasing or decreasing. You you get you get marks from that, but you get good marks when you also do the calculative work. So that's where level 3 gets you to, close to the distinction range. 78, 84, 81% in 2023, 80% for the IB papers in 2024. And of course, the level 4 questions around an aggregate of 10%, 13%, 7%, 9%, and 10%. And this is where the CAPS document also recommends that they are capped. Okay, so that's the analysis of the questions we have to deal with. So the focus of our masterclass is to maybe discuss level 3, level type 4 question approaches. So I'll start talking about a question. A level 4 question from chemical equilibrium. Okay, so this is a level 4 chemical equilibrium question. I'm going to discuss how to approach it. I think it was in the paper written last year by the grade 12s. Okay, so level 4 question has a lot of information usually, and I don't want you to let it threaten you. You just need to read it strategically. So this is a chemical equilibrium question. I just wanted to highlight chemical equilibrium there. So carbon monoxide gas, right? CO gas reacts with water vapor, which is a gaseous water, at some temperature, T Celsius. The reaction reaches the chemical equilibrium according to this balanced equation. So there's your chemical equation, carbon monoxide and water are the reactants, and then the products are carbon dioxide and hydrogen gas. So initially 0.6 moles of carbon monoxide gas and 0.6 moles of water vapor, 0.1 moles of carbon dioxide gas, and 0.1 moles of hydrogen gas were mixed and sealed in a 2 cubic decimeter flask. I don't realize I started until I have to read numbers and units. Okay, so that's the information given. If the equilibrium constant Kc for the reaction at this temperature, unknown temperature, is 4, the Kc value is 4, calculate the mass of the carbon dioxide present in the flask at equilibrium. So these things are thrown in with the initial moles, and it's allowed to achieve equilibrium. And then what is carbon dioxide? What is the mass of carbon dioxide present in the flask at equilibrium? I like chemical equilibrium because chemical equilibrium is really understandable in terms of the tool that we're given to understand it. So this is a rise table. So when you do a rise table, you obviously identify the species from the equation: carbon monoxide, water vapor, carbon dioxide, and hydrogen gas. And you write their stoichiometric ratios in the equation. So if you go back to the equation, um, so the stoichiometric ratios are the numbers in front of the mole numbers in front of the names of the chemical species. So there's one here. Just because we don't write one does not mean it's not there. It's not zero. So there's one there, there's one there, there's one there, there's one there. So you enter those stoichiometric ratios into your rise table, and then the initial moles were also given. So the initial moles were 0.6 moles of carbon monoxide, 0.6 moles of water vapor, water gas, and then 0.1 moles of carbon dioxide and hydrogen gas. And now you must use the rise table to anticipate the change in the reaction. So stoichiometrically, to achieve equilibrium, if carbon dioxide changed by X times its molar ratio, it's a stoichiometric ratio. Water will also do the same because they're 1-to-1, right? So they're decreasing by X, 1 times X, 1 times X. And then the products will increase, right? Because the reaction does go forward by X, 1 times X as well, 1 times X. And then at equilibrium, therefore, it means that 0 minus X moles exists, 0.6 minus X mole exists, 0.6 moles minus X exist, and 0.1 plus X and 0.1 plus X of the products exist. So that's the use of a rise table. The question was calculate the mass of the carbon dioxide. So maybe we can talk about how the calculation could be done. So I want you, as an exercise right now, to write for me the Kc expression at equilibrium. Given these moles that I have and the volume of the flask, write for me the Kc expression at equilibrium. I'm going to give you 5 minutes to do that. First person in will end the exercise. So I want the Kc expression. Write it. I mean, you're gonna type it, right? Or you can write it, take a picture, send to the WhatsApp group, and I will come find it in your group, your grade 12 group. So you have until 20 to 7 to do this exercise before I show you what the next step is. Mm.
But Mavo, they'd
Yes.
like you to share the screen with the question.
Oh, did the screen move?
Yes, it
Yes.
did.
Ah, okay. Sorry about that. What's Babala saying about new technology and old technology? Why has my screen disappeared?
Chemistry Masterclass 10.
Can you see it?
No,
Luvugo,
we're still on the WhatsApp page.
the group WhatsApp. Okay.
Yeah.
Sorry, I'm gonna have to. I'm going to have to.
You can just click the tab next to the WhatsApp. I think that's the actual Chemistry Masterclass tab.
Okay. Sorry, there's something blocking me from seeing it.
Oh, okay. I can share it on my side.
Okay, there it is. Sorry.
Yeah. All right.
You see it now?
Yes.
So write the KC expression. The first person to submit it is going to end the wait. We have 2 more minutes left, so maybe I should add 3 more minutes. 6:42, I will start showing you how it's done. Oh, so how did I share this? Why is it always showing me? I shared there. Why did I share? I shared Google Chrome as an application. Oluwetu Luvugo, please answer me. If I click on something else here, can you still see the question?
If you move away from this screen, we'll move with you. So I can share this, and then you can quickly check something else.
What are you seeing on the screen?
The rice table, chemical equilibrium.
Oh, so that's what I wanted to know. If I touch on, if I open another application that's not Chrome, are you still there? Then you're fine. Sorry, let me do my own thing then.
All right. Obuche has submitted an answer.
Okay.
Okay, so when you open another app,
Yeah.
there's a gray block on top of the screen that you share.
Okay. Okay. All right, I'm back. So where's Bush's it's on WhatsApp, right? Yeah, which I want it in terms of the X values as well. So don't stop at this. Sorry, I didn't, if I wasn't explicit. So the KC expression in terms of whatever you have on the table there. So what is the concentration in terms of X? What is the concentration? What is the concentration? What is the concentration? Go for it. So Luvugo, do me a favor. While I go pull the actual calculation, please please share this screen.
All right.
So I'm going to stop sharing. I could have just gone to a different, shared this screen itself in this other app, but I want to keep information in the Google form. So I want the students to have access to the information. All right. Answer. Right, so awesome. I see, what's his name? What's her name? OJ Manga has completed the work submitted by Lu.
Would you like me to
Oh,
stop sharing?
yeah, we can stop. You can stop sharing. So anyway, OJ Manga. Ubuhle. Someone is speaking.
Yes, sir.
Anyway, so let me take over the reins.
Yes, Obuse is got his microphone on.
All right, so Buhle, if it's you submitted, again, OJ Manga is what I'm seeing on my screen. This is correct, that's what you did. So the KC is equal to the concentrations of the products over the concentrations of the reactants. And the concentrations are just those mole values divided by the volume. And the volume was two cubic decimeters. I've just simplified everything here because I know how to do maths. But these two will multiply and square up. And the denominators also will multiply and square up. And in order to calculate the mass for this, obviously you have to solve for x, right? So most students would not do what I'm doing here. So they would cross multiply, right? And then KC is 4. And then they will start expanding the binomials. And that will take forever or introduce other errors, I think, that students are prone to. So what I'm doing a difference of squares. So 4 times this denominator is a square, right? This is 2 squared. And that is also a square if I bring it over to the other side and equate to 0. So this is a masterclass. I'm showing you best practice. You can use it or not, but I'd like to think that when you see something that shortens your work, you'd like to take it. So a difference of squares means that 2 times this bracket plus this bracket is the one factor. And then 2 times this bracket minus this binomial is the other factor. There's 2 factors there, which I can now expand there. 0.6 times 2, 1.2 times 2, and then I can simplify, and that comes down to these 2 factors. So I can simplify these big factors to these 2 factors. And I solve for x. So x is either 1.3 from this bracket, or x is 1.1 divided by 3. This we can discard because we can't take 1.3 from 0.6. Right? So we're limited. We don't have more to take when we had less initially. So we discard this for being impossible. And then we start calculating the mass that we are asked to calculate for carbon monoxide. So the mass of carbon monoxide is equal to 0.6 times the molar mass of carbon dioxide minus X times the molar mass of carbon dioxide. Right? So at equilibrium, this is the difference. What we had initially minus the change. Okay. Which I can factorize for the molar mass. 0.6 is just 1.8 over 3. 3 into 18 is 6 divided by 10 is 0.6. Which is easy for me to calculate. So you don't have to do this. You can start punching in values there. And we'll solve for X, so you can punch values there, and you get 6.53 grams. So this is how I've done it. So I've seen a lot of students do this question. Obviously, I'm tutoring private students on the side. And everyone wants to open these brackets, these squared binomials. And they get stuck because now it's too many terms. So, I mean, you're going to get 3 terms from this. You're going to get 3 terms from that. And if you didn't bring your math brain with you, you get stuck. Okay. So I offer this because we have a masterclass. And if there's anyone who has any question they want to ask, feel free to let us know in the group thing on the side, in the Zoom group text chat. But this is how you do this problem. But not only this problem, right? So I took a little one here, which I got from an IEB paper. Actually, I don't remember which year. From an IEB paper. The equation below represents the equilibrium reaction occurring in the solution of silver phosphate going into the ions, silver ions and the phosphate ions. And this is an endothermic reaction. So we're asked to calculate the concentration of the phosphate ion in the saturated solution, right? I didn't say this solution is saturated, but it is saturated. So how would you calculate? Because you have to do the same thing that I did, right? You have to do your rice table, account for the change, get your expression for Kc, and then solve for the concentration of the phosphate ion. This is another moment where I'm going to keep quiet. The first person to answer this and get it right within 5 minutes, I'll stop. Otherwise, when no one gets it, we'll discuss it. So 0.1 wants you to calculate the concentration of the phosphate at equilibrium in this equilibrium reaction when Kc is 8.9 times 10 to the minus 17. So in the other thing we just did, Kc was 4. Now Kc is much smaller than 1. What is the concentration of the phosphate in the phosphate ions in the saturated solution at equilibrium?
If Jaliz, as many of you as possible must please try and attempt these questions so that you're able to see where you commonly make mistakes, where you're going to leave a mark on the table. This is the point of this masterclass. So please use this chat box or the WhatsApp discussion group. You can take a picture of your solutions, whichever way, just so that you are able to really leave here knowing how to master these questions.
I've changed my usual location for doing work. I'm in Queenstown in the township. So if you're hearing a lot of people singing outside, I apologize. It's Mgidi season this end.
It's nice. We can't hear it, so don't worry about it.
Awesome.
While the FJLers are working, Mavo, I just want to confirm that Google link that we're going to share with the FJLers later on for the quiz. Is it the same one that you shared to Budluvugo earlier on today?
Yes, it's the same one, but I can share it when the quiz begins.
Okay, perfect. All right.
I'm going to share it in the WhatsApp group, the grade 12 WhatsApp group.
Maybe even the grade 11s.
Grade 11s and 10s. Okay.
Yeah.
I'll share it with the grade 11s as well.
All right, perfect. Thank you so much.
I have access to that. Even if you get stuck just doing the rice table, send through whatever you have, and then we can talk on top of that. I also want to say, obviously, you can solve this. You can do this maybe in some long-winded way. I'm trying to zone in on a more efficient and useful tool. Rice table is like a free body diagram. No one ever says, oh, use a free body diagram to answer these questions, okay? We might ask you to draw a free body diagram initially, maybe for one object. It's up to you to realize, oh, I can draw a free body diagram for the other object for myself. The free body diagram is not for the marker or retired marker. It is for myself to use. So a rice table is the same thing. No one is going to say, when you're working with equilibrium, chemical equilibrium equations, use a rice table to simplify your life. We're just going to ask and see if you learned anything, if you accepted the best practice of a rice table. So please get to it. It's gonna go open for my cat.
All right. I'm hoping that just because we don't see anything in the WhatsApp groups or in the chat as yet doesn't mean that you aren't attempting to solve this problem and answer this question, FGLers. Really important that you do so. Mavo shared just the importance of understanding the trends and what will be asked in a question paper. Swabalu also spoke about that. And also how to master these questions. I think that's the trick. So we all are chasing distinctions, but putting in the hard work and, getting it together as a group is what we need to do here. That's the point of this masterclass. I encourage you once again to go ahead and do your attempts.
Sorry, I'm speaking here, but my mic is not on. I see there's a question from someone, but now I've lost the question, asking how is it possible for us to do this calculation without a given volume? If you noticed the Ka Kc that we calculated, when you started with the concentrations, right? You started with the concentrations. All right, so let me try and get to my okay, so I'm going to share my screen because for some strange reason I'm not organized. So stop sharing and then share again. Right. So okay. Everyone can see my screen. There's our reaction. H3PO4 is
Yes, we
not
can.
what we have. It should be AgPO4. Sorry, I don't know where my file is. That's what happens when you work overnight. What was Babalo saying? If you cross night? Okay, I found the file. I found the file. While Olwet is laughing, I'm found it.
Yes.
Ugh, okay. I said to Cindy, I'm gonna try and keep everything contained, but it's not as easy as I thought it would be. All right, so you should be seeing on the screen my rice table. All right. So first, identify the species. I have the solid on the left-hand side. I have the ions on the right-hand side. Okay, there's the solid, here are the ions. And then I write the stoichiometric ratios. 1 for the reactant, 3 for the silver ion, and 1 for the phosphate ion. We don't know what the initial moles are for the reactant. They were not given, so I'll just put in a variable there. But I know that initially the moles were not there, was 0 for the ions. So what happens? Stoichiometric ratio for the silver is 3. So the change will be a positive x. And stoichiometric ratio for the phosphate is 1. The change will also be a positive x. So 3 times x, 1 times x. These are the moles at equilibrium. But when I write Kc, I write Kc in this way.
But Mavo, can you maybe just have a look at the WhatsApp group? Obuhle has also given a response on WhatsApp.
Okay. Yes, Bushle, that's the table. Awesome. So I'll quickly share Bushle's calculation. Wait, Bushle, what happened? Oh yeah, so no, we got the same answer, sorry. We just represented the number differently. So let me go back to why am I stuck in my head? To what I was showing on the screen. So Bushle did the same thing that I did. Set up the Kc. The Kc is going to look like this. Concentration 3x to the power 3. Remember, the concentration variables get raised to the power of the stoichiometric ratios, something that didn't happen, that I didn't discuss in the previous question, because all the powers were 1. So in this case, 3x to the power 3, x to the power 1. So these become powers of the concentrations. And yeah, so that's Kc. I solve for x. Bushle plugs in. I'll show you now Bushle's approach. Starts plugging in values. I only plug in values step before I finish the calculation. So I solve for x. From this is going to be 3 squared 27. X cubed times x is x to the power 4. So it's going to be 27 times x to the power 4. Divide by the 27 to isolate the x, and then I take the 4th root to solve for x. And you'll notice that the x is the concentration of the phosphate. So that means the concentration of the phosphate is equal to this, which is just the square root of Kc over 27. This is just maths. I plug in the value given for the Kc, 8,9 times 10 to the negative 17, divide by the 27, and you should get 4,26 times 10 to the minus 5. Okay, I want to share Boucher's calculation as well. Share another screen. Doesn't matter how often I use Zoom. I'll always not know how to share. Right, so that's Boucher's calculation, exactly like mine. Well, that is, we get to the same conclusion. Kc is given by that. Raised to the power. See, now you keep having to write this number every time to get to the next step. That's why I don't write numbers until the last step. But I mean, there's nothing wrong with it if you're comfortable doing this. That's it. And then there's 0,00043 at 0,000426, which rounds up to the same thing. Okay. Is there anyone who wants to ask something on this? In fact, the question that I saw in the IB said, show that the phosphate ion concentration is this value. But I had to take it obviously and and see if anyone would be able to solve it without being guided by the question. So I made it a level 4 question, but in the exam it was a level 3 question. Because it's just asking you to show that that is the answer. I'll try and share the proper question. So that's the use of the rise table. There was a genuine question that I liked. How can you calculate if you don't have the volume? I definitely think that maybe I didn't take down the question properly. Because this will be the case when the volume is one cubic decimeter. Sorry, I'll just check this quickly when we're done, when you're doing your quiz. And if I have to make that correction, I'll make that correction. So that question was valid, whoever asked it at Ansakhumbul Bangban. So the volume would have to be a volume of one cubic decimeter. Okay. But rise table, Kc, calculate. Is there anything I want to say? There's nothing else I want to say here. Okay, I'm gonna go back and share our Google form. Share Google form. So the next question is a level 3 question. I think we tackled it before there was a June exam, but I just wanted to emphasize the importance of this, because I did this calculation in a roundabout way as things stand. I don't have the question properly here. Can I grab the question? Please be patient with me. 2024, 2024. In fact, let me show the question because transferring it there is going to be a problem. All right. So this was the question. A hydrochloric acid solution HCl of 0.1 moles per cubic decimeters is titrated with the prepared potassium carbonate solution, K2CO3 of unknown concentration. Here's the balanced equation. These are part of your quiz, so that means I copied the question well for the quiz, but not for the discussion. So the question says, calculate the concentration of K2CO3 solution, or the K2CO3 solution based on this information. Okay, so remember those volumes, 20,05 and 20,15. I remember the concentration of the acid, if we have to. How would you calculate this? How would you calculate the concentration of the potassium carbonate solution? So this is what I do in the Google form. So this is an acid-base reaction. So the volumes you saw there were the titration volumes, the 20,05 and the 20,15 were the titration volumes. So, and this reaction is at an equivalence point. Obviously, when you're titrating, you titrate to equivalence point. How would you calculate the concentration of the analyte? Or, I mean, it's called an analyte because we don't know its calculation. We know there's 0.1 moles per cubic decimeters of the acid. So the analyte is the K2CO3, the titrant is the ACl, even though in the setup, the equipment is set up differently. So the acid is in the flask, and then the analyte is in the burette. So it doesn't change the fact that that's what we're analyzing. So I did it a long way, calculated moles and whatever. But I think where I left it off was that this is a useful equation. This is a useful thing to know that at equivalence point, the stoichiometry will be observed. That means at equivalence points, the moles of the analyte and the moles of the titrant are 1 and 2. Okay. So the ratio is the number of moles of the analyte and titrant. But also we know that number of moles is equal to volume times concentration. This is the concentration we're looking for. So the denominator also has volume times concentration. Like you know me by now, I solve this without the numbers. So I manipulate this to solve for Ca. So the concentration of the analyte, which is what we're solving, looks like that. If you cross multiply by the Vt, divide by the Va. And the volume of the titrant in the beaker is always 25 mils, or 0.025 cubic decimeters. So I haven't converted the volumes because they will cancel in units. Okay, so I've kept them the same. It's the same thing as dividing by 1,000. If you divide by 1,000 there, you divide these two numbers by 1,000, the thousands will cancel. Okay. And you have to find the average from the titration volumes. So this is, I mean, I say it's level 3, but that's what you do with titrations. You get different runs, and then you find the average of the runs. So if you have 5 runs, you average over 5 volumes at equivalence point. If you have 2 in this case, you average over 2. And we kind of sort of discussed this before you wrote your exams, but I just wanted to present it nicely. By the way, when I share the Google form link, all of these things will be there in the Google form. So whenever you have data, you can still find them. So don't panic that these are one solves and you have to transcribe quickly and so forth. Okay. So that's a level 3, level 4 question in acids and bases. I wanted to share it because of this equivalence point story. So the moles at equivalence point are the stoichiometric moles. So remember this. You don't have to memorize a lot. If you just remember what happens at the equivalence point, the moles of the analyte and the titrant observe stoichiometry. Okay. And yeah, so you'd find your concentration for the analyte K2CO3 to be that value, which we've discussed with the grade 12s. I'm looking at the time, and I have one last one, which you don't have to calculate. I also want to emphasize. So the question says K2CO3, so the K2CO3 solution used in the titration was prepared by completely dissolving a mass of the potassium carbonate of 6.525, which is a hydrated molecule, in 600 cubic centimeters of water. So that's how the concentration was got. Calculate the value of X, which is the hydration molecule factor here. Calculate the value of X in the formula K2CO3 times X, or X H2O. How would you do this? I like this question because it teaches a lot in just one go. So obviously the concentration of the hydrate is this. We're looking for X is equal to the number of moles of the hydrate over the volume of 600, right? But the number of moles is moles divided by molar mass. So moles, so it's mass divided by molar mass. So M is in grams, molar mass is in grams per mole. The grams will cancel, and the per mole will go up top and become a mole. And a mole divided by volume is the concentration, right? That's what we're going for here. And just to make people feel easy, I start substituting for the mass. So we're told the mass of the hydrate that was used to dissolve and make the solution was 6.525. There you go, 6.525 grams. And the molar mass is the sum of these compounds inside the hydrated molecule. So it's the molar mass of the K2CO3 plus X times the molar mass of water, right? Or the molar mass of X waters. And then the volume was 600. In this case, we divided by 1,000 for the decimeters. So there's really no reason why this is not the same as that. Okay, so these two are the same thing. The concentration is the same, right? So I replace this with just this K2CO3. And I start substituting. Oh, I solve for X. So as you would know me, I would solve for X first. So I divide by the 6,52, or rather, I cross multiply by this whole thing to the other side, to the left, and then I divide by the concentration. So I have this divided by this concentration and the 6. There they are multiplying each other. And then I bring over the molar mass of the K2CO3 to the other side. It becomes negative on the right-hand side. And then I divide by the molar mass of the water to isolate the X. Okay, so this is just maths. I encourage you to be very good with the maths. What Babalo is not telling you is that there at university, he didn't like probability in high school. There's a lot of mathematics that goes into probability if you end up doing statistics or actual sciences. There's a lot of maths that you need to master, and you can't keep writing numbers before doing calculations. So I encourage you to be on top of manipulating algebraic expressions to solve what you're looking for. And then only now do I substitute fully. So I know the molar mass for water is 18, 2 plus 16. And so this we've already calculated in the previous calculation, which I just showed you, the concentration of the potassium. And then, of course, we need to calculate the molar mass of the K2CO3, which comes out to that. And you'll find that X is about 2, so therefore X is 2. I really wanted to emphasize this because there's a lot you can learn from understanding the fact that the concentration of the hydrate is the same as just the concentration of the K2CO3 without the hydration molecule. Because you're dissolving everything in water. So there's enough of these. The same of these K2CO3 in this hydrated molecule will be in the solution. This is key. I know it might be trivial to some of you, but for a lot of you, I want you to think about it. So I'm saying here, there is no reason why these two are not equal. So in other words, I'm saying they are equal. So that will be the level 3, level 4 reasoning that you have to make to do this calculation. And of course, it has a lot of steps. So yeah, it's definitely level 4. And you find that your X is equal to 2. It will be interesting, and I've tried it. I put X equal to 2 and calculate if that concentration is the same as the one I got of 0.062. Okay. That's my piece on that. Yeah, so this is the question. Yeah, it looks like I'd swap things around for myself. I think I can stop there. There is a calculation I wanted to do on rates of reaction, but it doesn't look like it uploaded. So I'll have to upload it while people are doing the quiz. That's kind of me with the time.
All right, so we
Uh,
are at 27 minutes past 7, so there's still time. So we're allocating, is it 30 minutes to the quiz?
it should be 20 minutes, man.
20.
So I'll ask, because we need to discuss and award people in the last 10 minutes.
Okay, sure. All right, so FGLers, are there any grade 10s here? Maybe the grade 10s want to give it a shot. Do you think it'll be too tough on them? Some of the concepts they haven't covered yet, no?
Yeah, I know this is too foreign for grade 10s, but I mean, they can try.
All
They can
right.
try. So what I want to interrupt you. So I'm going to take the link, shorten it. And then I'm going to go to the grade 12 WhatsApp group. Did I unarchive it? There it is. I'm going to paste the link there for the Google form. Before you start, give me 2 minutes to help you navigate, or we must talk if there are issues. People must text and say they have issues. So I need to find FGL 11. There's the 11. I'm also pasting the link in the group. Just for fun, I'm going to include the grade 10s. All right, so I'll put everything in for 11 and 10 and for 12. So click on the link. So let me help you navigate first. So when you land there, if you scroll down, there's a place where you have to enter your name. I need you to enter your name. The question is, what's your name? So you're going to type your name there. My name is, I'll type my own name. Okay. So I need you to type, it's a required question for you to answer. There's an asterisk. And I want you to type the name of your school. So my school is FGL High. Right, so you're gonna scroll past the presentation I gave you earlier. And you get to section 5 out of 8. The quiz will start there. The first thing you need to answer is what is your name? The next thing is the name of your school. Hopefully you can enter those. And then you will scroll down until you see 1.1.1. There it is. So that's where the quiz starts. It says define the term dynamic equilibrium. And it's a multiple choice question. Why is it doing that to me now? Showing answers.
Stop
Gosh.
scrolling, stop scrolling.
I need to, yeah, stop scrolling. Anyway, let me click on a different question. Yeah, so we have four things to choose from. So the way this one works is when the rate of the forward reaction is equal to the rate of the reverse reaction, that's the definition, or when the stage of the reaction, when the concentration of the reactants don't change. Gosh.
Just a reminder, FGLers, that we are awarding the top 3 for this quiz. So we do the marking as soon as the quiz is done, after your 20 minutes is up. So the first, the winner will get $1 million Genius Dollar points, and the The runner-up will get 750,000 Genius Dollar points, and the second runner-up will get 500,000 Genius Dollar points. This has been just, everybody smiling all the way to the bank this evening, and we just want to top it up with that. So give it your best shot as soon as Mavo says it's a go.
Right, so you have first two answers, and then the last two answers are both the first two answers are correct, or neither of the first two answers are or first three answers, neither of these answers above are correct. Okay, so either both of them are correct, neither of them are correct. So that's your option. You must choose which one that is. 1.2 is also an equilibrium. It's the drop-down menu. So on your side, there will be a drop-down. If I can't click on it because it will show you the answer. I think this is also a drop-down menu. So I think they should start answering from 1.1 all the way to 4.21. 1.1 all the way to 4.21. So this is a first for me. So if there's an issue in terms of whether you can read the questions or not, I'm assuming everyone participating has some smartphone. I have a Mobicel.
So he
Why is
can't.
it ghosting? It's ghosting my Mobicel. So I have a Mobicel, which works fine. So I'm hoping all your phones work fine. Go for it.
All right.
You have
I'm going to ask
20.
Hugo to put on the timer. His timer has started, so he's going to let me know when we are at 2 minutes left.
Okay.
Good
Yeah, all
luck,
the
FTLers.